Introduction. Water quality testing is crucial for assessing the health of aquatic ecosystems and safeguarding human and environmental well-being. By monitoring various physical, chemical, and biological parameters, scientists and environmental professionals can identify pollutants, assess ecological integrity, and implement management strategies to protect water resources. In this guide, we'll explore the methods and procedures for performing water quality testing in aquatic environments, empowering individuals and organizations to contribute to the conservation and restoration of freshwater habitats. Preparation and planning. Identify testing objectives. Define the purpose of water quality testing, whether it's to assess drinking water safety, monitor pollution levels, evaluate habitat suitability, or comply with regulatory requirements. Determine the specific parameters and sampling locations based on project goals, regulatory guidelines, and ecological considerations. Select appropriate testing methods. Choose the appropriate testing methods and protocols for measuring physical, chemical, and biological parameters of interest, such as temperature, pH, dissolved oxygen, turbidity, nutrients, metals, and microbial contaminants. Consider factors such as equipment availability, sample collection techniques, analytical procedures, and data interpretation requirements. Sample collection and handling. Obtain sampling equipment. Gather the necessary sampling equipment, including clean containers, sampling bottles, meters, probes, and field kits for measuring various water quality parameters. Ensure that all equipment is properly calibrated, cleaned, and sterilized to prevent contamination and ensure accurate measurements. Collect representative samples. Follow standardized sampling protocols and procedures to collect representative water samples from different locations, depths, and times to capture spatial and temporal variability. Use appropriate sampling techniques, such as grab sampling, depth-integrated sampling, or composite sampling, depending on the characteristics of the water body and the parameters being measured. Laboratory analysis and testing. Analyze water samples. Transfer collected water samples to the laboratory for analysis of physical, chemical, and biological parameters using specialized analytical equipment and techniques. Conduct tests for parameters such as pH, temperature, conductivity, dissolved oxygen, nutrients, nitrogen and phosphorus, heavy metals, organic pollutants, coliform bacteria, and algal toxins. Quality assurance and quality control, QA, QC. Implement quality assurance and quality control measures to ensure the accuracy, precision, and reliability of water quality data. Include replicate samples, field blanks, and certified reference materials in the testing process to assess analytical variability, identify potential sources of error, and validate results. Data interpretation and reporting. Analyze and interpret results. Interpret water quality data in the context of established water quality standards, regulatory limits, ecological thresholds, and historical trends. Identify patterns, trends, and anomalies in the data to assess the overall condition of the aquatic environment and evaluate potential impacts on human health and ecosystem integrity. Generate reports and recommendations. Compile water quality data, analysis results, and interpretation findings into comprehensive reports, summaries, or presentations for stakeholders, decision-makers, and the public. Provide recommendations for management actions, pollution control measures, remediation strategies, and long-term monitoring programs based on the assessment of water quality parameters and environmental risks. Conclusion. Water quality testing is essential for assessing the health and integrity of aquatic ecosystems, protecting human health, and ensuring sustainable water management practices. By following standardized protocols, employing appropriate testing methods, and interpreting data accurately, individuals and organizations can contribute to the conservation and restoration of freshwater habitats, mitigate pollution impacts, and promote the sustainable use of water resources. So let's work together to monitor, protect, and preserve the purity of our aquatic environments for current and future generations.